My name is Mathangi. I head the data organization for GoFood at Gojek. I have around 17 years of experience in data science and analytics. I have been part of various organizations driving impact through data all my career. I have few patent grants to my name, and last year I published a book on natural language processing. So in this session, we are going to talk about a key area that bothers in the data science industry. We are going to see how to create impact through data science. What are some of the things to avoid? What are some of the things to look forward to? That's what my session is going to focus on. This session we will talk about at an organization enterprise level, how do you create impacts with data? There is a lot of buzz and talk about data science. There are a lot of hackathon kind of competitions, but the real world of data science is slightly different from the world we see through hackathons, etc. Right? So, and hence it is important to understand how do you work with an entire organization climate? How do you work with various stakeholders? How to choose your right problems in order to make impacts that are meaningful with data. Data-driven decisions, we can divide broadly into two phases. One phase is data-backed, another is data-led, right? So this is kind of captures the history of data-driven decisions so far. The initial phase, what I'm calling as data-backed is basically set of hypotheses that got generated by business or different stakeholders, and data was just used to validate a hypothesis or not. Whereas the current phase which we are part of is more data-led. From the phase of validating hypothesis, from the data-backed phase, we are now in a phase of generating the data itself, generating the hypothesis, and then machines are able to take large-scale micro decisions at scale, right? So we're going to a little bit do a sneak peek view of what was data backed and what is data led before we move on to see how in the data led world we kind of create impact through data science. So this was our data backed world. Some of you who have been around for a long time in the industry would know that the hypothesis that got generated by various teams in the company, and then data was more used to validate whether one exhibits a phenomenon or not. For example, let's say a campaign was successful or not, right? Whether people are liking a product or not, or a little bit of research in terms of what are the top factors that is driving the sales and things like that, right? It was more recommendations, insights, at some point actionable insights, but not primarily predictions. So it set way for certain things like better experimentation and how do you design a set of experimentation so that the post analysis will be better, etc. But a more static view of data and not dynamically using the data to change the course of business. From this phase, we moved to data-led, but still human governed, right? It's not like data is completely self-piloting this whole show. There is quite a bit of human governance being involved in it. So why did this happen, right? And how did this happen? How did this shift happen from data back to data led? So there was at one point, possibly the late, somewhere around the 2005 to 2010, there's a boom of data, boom of internet companies that was investing big time on data. They were collecting, instrumenting data at scale. That's one thing. Second, the infrastructure from the engineering organizations also exploded. Infrastructure became cheap, became more affordable and accessible. The third thing, this did not happen during the late part of the first decade of 2000, but it happened much earlier. So the algorithms per se have been around for a long time, possibly from the 1950s in some cases. We even see some mentions of deep learning algorithm in the 1990s, etc. Right? But the full-fledged usage of these algorithms came into picture when data got available and infrastructure became accessible, so that the large scale data science models can now run. And they also had use cases, consumer facing use cases, that were made possible, to make these things come together: data, infrastructure, and the algorithms behind it. So that's the phase we are currently now. But what happened at the beginning of the phase, right? There was a lot of buzz, there's a lot of media articles, there was a lot of enthusiasm. A lot of people joined the bandwagon without totally understanding what it is. Sometimes the revenue improved and there were some successes. But did this last? No, that right. So it kind of because people did not understand a lot of these use cases totally well. There was a dip in adoption of data science. There were a lot of failures that happened. So people at some point thought that, okay, this may not be this may not be all magic, and this is a lot of buzz than real meaning to it, right? So that's the phase we landed up in, and this can be very clearly explained through Gartner's hype cycle, which is a plot between time and how visible the technology is in the market. Initially, the technology trigger, everybody, early adopters are there, and there's a lot of buzz. People want to get onto the bandwagon without understanding the technology fully. So this also happened in data science and machine learning. So it had a peak of inflated expectations. Possibly this is the point at which we saw a lot of use cases on computer science, computer vision, and and things like that, and people thought there is a one fit solution to every data science problem out there, and it is going to change the world and things like that. So that was your peak of inflated expectations. From there is a trough of disillusionment where people say, okay, this is not something seems to be of value. It's more hype than there is value to it. And then there is a slope of enlightenment. I think we are somewhere between the slope of enlightenment and plateau of productivity with respect to understanding of data science. We kind of are operating at a point where we are more matured. We know possibly where to use the solution, what are its limitations, how do you shape this up, how do you set expectations so that the right impact is expected and the right impact gets generated. So that's the cycle we are in terms of Gartner's hype cycle with respect to data science. So before we say what could make it successful, we need to understand why did the initial wave fail, right? Why did the trough of disillusionment in the Gartner's hype cycle happen? Well, so there are a few reasons that I think have happened, and I've listed this out here. There was a blind way of operating with AI. People applied AI on anything and everything. You need for AI to work, for a data science solution to provide a meaningful, impact. There needs to be a constraint. The constraint needs to be there. There has to be a problem. Then you are maximizing, minimizing something. Then the problem exists, right? Take for example, if for a growth stage startup, the marketing budget is not well defined or not well limited, then if and the focus is completely on growth, then there's no point maybe applying AI there. Possibly you can target initially all of the users and then get data and then make your constraints from there, right? So if there is no limitation and no constraint, there is no point in applying data science. For example, another example could be for fraud, right? If there is not a huge cost of fraud, then maybe at the initial stage in the company, we may not want to use data science to accurately figure out who's a fraudster and who's not. So it's important to identify problems that presents constraints that the data can help identify. Another is believing in a black box, right? So data scientists at the initial phase, thought that, okay, we will build a black box, that's magic, because we are using tons of data, because there are complex algorithms that is operating in, that itself will provide an impact, right? Now, this logic has to get challenged. So one of the things that I practice, in my work is whenever there is a predictive model that gets developed, we challenge it with a naive logic, right? So an example is, let us say, a classification model is predicting what will the customer likely to buy next. Now, product A, product B, product C, product D, right? So can your naive logic, which is just based on pure distribution, right? Pure frequency distribution, can it be, is your naive logic as good as your model, or is your algorithm better than the naive logic, is something we want to test, right? let us say we want to target 10% of users for an upcoming marketing offer, then and you have built a machine learning model to solve that problem. Now, is your machine learning model better than a random logic of targeting randomly 10%? Now, these things may look very simple and silly to even question a large scale machine learning model with tons of features, but believe it or not, a lot of times the random model could do better, right? And it may point out some errors in the algorithmic process, in our understanding of the landscape of the data, or in understanding the landscape of the business. So it's important that we challenge complexity as we want to build complex solution, as we want to drive impact through AI. It is also important to have a good guardrail with with a naive or a random logic, or maybe the business is already having some rules or some expert systems out there. Now, does your AI, complex AI solution, does your deep learning models kind of beat the existing logic? Has to be tested even before the model goes into production. Tweaking it too much, this was another thing that people did. This is the exact opposite of complexity that we saw in the last slide. When people blindly went ahead with, just because it's complex, it's going to be great, and put out the solution there. The other end of the story is there were people who were very suspicious of complexity, and they wanted to understand everything that goes on with it, and started challenging with their expert knowledge. So and hence a lot of these complex solutions never saw the light of the day, or they saw the light of the day with enough and more manual tweaks in it, right? So for example, somebody might have built a risk score model, and the risk manager says, no, I think the model is doing good, but I want to add few heuristic conditions on top of the model, right? This is also not great, because you are diluting what the model is predicting at the end of it, and it is not totally data driven, right? So tweaking it too much is also bad. And also, like we saw in the last slide, applying the complex solution without any looking for any fallouts are also bad. This is a famous quote from Jim Barksdale, like, if you have data, let's look at the data. And he was the CEO of the company of Netscape. And if you all have opinions, let's go with mine, right? So it's also important to go by data, challenge the complexity, but not override your heuristics on top of it. Then when these initial data science organizations got started in a lot of companies, they were built like labs, right? And we had a lot of academicians, joining the industry, and there was not an effective trade-off that got worked out between robustness to pace of delivery, right? You want your predictive models to be robust. You want them to give you the best possible impact. You want to make sure you have the best model out there, but not at the cost of time, right? So even a V1 solution, which is better than your baseline solution, would work better. So what happened was, a lot of times it was restricted to labs, and people thought it will take years to develop an AI solution to the current problem, and hence when the solution got developed, it was no more relevant to what was at hand, right? So and hence it is important to do a trade-off between impact and time, and cut that at the right point in time and go to a solution to the market. This was also not happening at the initial phase, because it was restricted to a few experts in the field, and for whatever reason, they also had their sense of launching the product only when it is fully well shaped. Now we have seen fairly what went off, and hence what should be avoided. To put it in a nutshell, so what could define the success of a data science are, I've listed some 8 points here. One of the first points is a well-constrained problem. So spend enough time in shaping the problem. Ask the question, what is the cost? If there was, so for example, it's a classification problem. So what's the cost of your false positives? What if you do not capture, all the frauds, for instance? So what is the cost to it? Or if the model goes too aggressive and penalizes genuine people as fraud, then what is the cost there, right? So constrain your problem, understand your cost, If there is no cause that you can identify possibly, then maybe it's not worth investing, the complexity in this case. Then there also has to be a changing data landscape. For example, take an allocation problem of online, cab services, right? So a customer X is booking a cab and it has to get assigned to a bunch of drivers in that area. So the set of drivers and their nature of accepting a certain booking constantly changes. Customer priorities to take the ride and their elasticity with respect to price also changes. So there is a changing data landscape which cannot be solved by just human understanding of heuristic rules or something like that, and that also warrants data science problem. So the data should be dynamic. It's not only it should be large, but it should also be dynamic. The customer behavior has to be dynamic. That completely warrants a data science solution. Third, is an odd culture that's open to machine-driven decisions. We saw this in one of our slides before, that if you tweak the model too much to human understanding also, it may not give you the right performance, right? So it's important an odd culture is open to experiment, try, pilot machine-driven decisions, and do not say, hey, the experts in this organization know better, or the risk managers or the marketing managers in this company, they understand the customers very well. So if your machine learning model is not aligning to their decision, then there is something wrong with the model. Now this has to change. There can be ways to question the machine learning models in terms of their impact, or offline impact, their estimated impact as compared to a baseline solution, kind of features that go inside the model, kind of interventions that you can take out of it, so on and so forth. So there are ways to question your machine driven decisions, but the one way not to question them is to second guess your expertise of what you know and what the model is throwing, and hence believe or disbelieve what the model is doing, right? It's better to look at it a little bit from that perspective of there are areas to discover, that is what the data is doing there, rather than completely judging a model based on human judgment of past knowledge. A grounded DS team, what I mean grounded DS team is people who want to take one step at a time, and they are questioning the current way of decision making in smaller steps rather than in bigger leaps of faith, right? So a grounded DS team would be able to empathize with the overall org culture. They will be able to empathize with the overall business problem. They will know when to put a fairly complex model to when to operate at a simple solution. They will also be more agile and able to get your things faster, and they are completely worried they are more focused on where the organization wants to go next rather than what kind of algorithms that they are putting inside their models. Well-regulated model building process, which is model governance. Like once the DS team builds the model, there has to be checks and balances, which is part of the model building process. Like how an engineering product gets run by a QA team, it is important to establish a regulatory and governance framework to a predictive model that will prevent a lot of things. One, it will make sure the model is robust, and then you are not getting unexpected surprises once the model goes live. It will also keep you protected in a regulatory environment. It will make sure data governance and things like that is taken care of. Some of the data privacy issues are taken care of, etc. Then a sixth one is experimentation DNA. So we do not know, especially when we are talking about very complex problems with changing data landscape, we do not know where the truth is, right? And the truth possibly lies in something that we have not experimented. And experimentation means failure, right? So acceptance to the possibility of failure, and acceptance to experiment and see. So whenever there is an experimentation, there is also going to be a loss of it. So if I'm going with option A, B, C, maybe one of the options is very suboptimal, because of which some of my customers may have poorer user experience. because of which some of the revenue loss are going to come. But as long as you are aware of it and willing to take that chance so that we are coming up with the best possible product, that's very important for a thriving data science organization as well, and also to create impact driven through data. The seventh is integrated teams are very important. Data, product, design, engineering, business teams, client-facing teams, the CEO of the company have to work together to make an AI product successful, right? Including the clients also. So you'll have to have your right product market fit. It has to be well defined. Design is very important because as long as the prediction scores, etc., comes from the data science model, what to do with those prediction scores, how should these interventions happen, how will the user experience hence will get impacted, how do you measure fallout on user experience, and how do you trade off user experience with the revenue. These are all some things not only with the domain of data. It is design, product, as well as business functions become very critical in making these trade-off decisions. So integrated teams are extremely key to the success of data science as well. And last but not the least, and that's why it's in bold, it's finally all of this is to solve a business problem, and all of this is to create business impact. And that, if everyone is aligned on that, if everyone is thinking that's where we are going with this journey, we are not going with this journey to create a hype, we are not going with this journey to put the best in class model at play, but we are creating this because AI is one way to make sure my customer gets the best user experience, and we as an organization can improve our revenues because of this, or we can save some losses because of it. If that is at the heart of guiding this entire journey, then a lot of these 7 points will automatically fall in place and business impacts will be made possible. So this is what I wanted to convey, and as each of you begin your data science journey or at different level of maturity of data science functions in your organizations, you could keep this in mind as some of this is possibly well known to you, but talking about it and sharing my view, I thought I could add something to your decision making process. Thank you.
For more updates from CXO TV, please like and subscribe to our channel.